My name is Adam Noonan. I'm a sales engineer here at Lenses, and this is our first Kafka live stream. So our goal for these sessions is a quick 30 minutes engaging conversation, but we can all leave with a little bit of knowledge and education component too, not just about Lenses, but also just Kafka operations, best practices, and architectural components as well. So as I mentioned, this first session will be on backup and restore of topic data to S3, different ways to go about it, pros and cons of each implementation, and our take on that architecture here at Lenses. Next week, we'll be talking about sourcing complex data from S3, so unique file formats, complex text files, or weird delineations for CSVs. We can handle all of that with our source connector, and we'll show you how. 2 weeks from now, we'll be talking about syncing data to your S3 data lake, some additional use cases and considerations to take for that. And then we'll wrap up the year bringing holiday magic to your Kafka streams processing with a little bit of SQL magic. As I mentioned, I'm Adam Noonan, sales engineer here at Lenses, and I'm joined by a full team here. So we've got Guillaume, our CEO, on the line, Andrew Stevenson, our CTO, Stefan's our director of engineering, and we also have Adamos, who heads product, and Matthias, our PS consultant. So if you have questions, feel free to raise a hand or chime in and interrupt. I'm trying to make an engaging conversation, but they'll also be able to tackle questions in the chat as well. Awesome. And we want to start off the session with a question, set the framework and our thought processes. And the starting off is, what are some reasons why we might need to back up Kafka data to S3? So what are situations we're trying to protect against? What are we trying to enable our company to do? Or what's a scenario that you've come across where you said, man, I really wish I had this backed up and I could just restore a clean copy? So feel free to chime in the chat or come online and let us know. See everybody's location: Berlin, London, Jersey, Brazil, all over. In Belgium. And that's okay. Due to budget constraints, I'm not in Vegas either. So you're not alone in that. Cool. So hopefully we've got some wheels turning. We're putting ourselves in that scenario of why would I need to back up topic data? And we have some out-of-the-box answers for you, some scenarios to protect against. One is obviously for disaster recovery. Catastrophe happens. Your entire cluster is offline. Maybe the data center melt down. There's a serious earthquake or tsunami. Maybe your AWS region actually went offline. Or maybe there's a ransomware attack and your entire cluster is now encrypted. You're unable to access those resources and unable to utilize your production data. So significant catastrophic event, impairing your entire cluster. You're now spending money offline, and you're unable to access that data. So serious situation where a backup of a full Kafka cluster would have been a good thing to do ahead of time. Another common scenario that we see is human error. So someone either putting in the wrong CLI command and dropping an entire topic, or more commonly, accidentally changing a topic's configuration to significantly reduce that retention period. So maybe your topic typically retains data for 7 days. Your new junior developer comes online, accidentally changes that to 7 seconds, effectively erasing your entire topic. Something to protect against and safeguard with governance controls, but also a good scenario to have a backup for. And then one advantage of having a backup is that you can actually intentionally reduce that retention for a Kafka topic. If you're following an event sourcing pattern where you're deriving state from a full event log, that can get quite expensive when you're keeping all of that data on a Kafka broker. And that's a hot commodity. There's other topics vying for that space too. You can save your organization money by reducing that retention period and backing up all of that data to S3 in a streaming format. So beyond just a single snapshot of a point in time, but actually streaming your backup into S3 and Object Store is the goal. And then another scenario is that a producing application is having some issues. Maybe that junior developer is back online again. He's producing a whole lot of data that is totally unusable to the topic. So the scenario then is that if you have a backup, you're backing up all of your data, you can effectively clean that data in S3 in your object store and then restore that clean copy to your production cluster. Things to keep in mind with that is that how that would affect ordering and consumer offsets, but all topics that we'll address coming up. So great scenarios on explaining the importance of backing up Kafka data. Now, how are you going to back up topic data? So opening up to the group again, does your organization have a backup plan for Kafka? If so, how are you doing it? Are you using connectors, producing applications? Yeah, would love to hear how you're addressing this need in your organization. And we don't have a plan right now. That works too. That's good to know.
Yeah. So what is my question that I have a multi-regional deployment of my Kafka cluster, right? So we have the backup in different regions. So if suppose something happened to my one region, one node, or any other complete cluster, but still I have the backup in other region. So do you think that should we keep this? Do you think that we should use this S3 connector in that case also?
So the question is, we've got multiple Kafka clusters in different regions, and
Yes,
the goal
right.
is to have a region-specific backup for each cluster and whether or not our S3 connector can meet that need, correct?
Yeah.
But I'm guessing, Harry, you're replicating data between those regions, or you're not replicating data right now?
Yeah, data is replicating.
Yeah, okay. Are you using
Cluster
Mirror?
linking.
Are you
Yeah,
using
we are
Mirror?
using cluster. Pardon?
Cluster linking from
Yeah.
Confluent.
Yeah.
Okay. Yeah, I think in a couple of slides we'll answer that. We'll touch on that.
Okay. Thanks. Yeah.
Thank you for chiming in. The implementations that we have to talk about are obviously, like we mentioned, not backing up topic data. So we're relying solely on that data within Kafka as our single copy. Another option is proprietary connectors. So another company offering connectors that has an open source sync, but the source connector is actually licensed. That can give a false sentiment of security because you are syncing it to S3, but your backup is only as good as your restore. So if you're not able to use a source connector and consume that back into Kafka, then you're left with, in a disaster strike, producing your own application or coming up with an alternative method of consuming that data back into Kafka, and importantly, ensuring ordering and all the metadata is the same. Another option, like Harry mentioned, that he's using is cluster replication. So you've got one Kafka cluster, and you're replicating directly to a passive cluster as your backup or failover Kafka cluster. Two ways you can do that is with MirrorMaker 2 or Confluent Cluster Linking or Replicator. And again, more on that in a second. And then another method or implementation would be a storage backup. So a snapshot of the underlying storage at the broker level, which again isn't following the streaming mindset and paradigm of as an event happens, an event occurs, event-driven architecture, but rather chronologically based. So a chronological snapshot of that topic there, which has its own caveats and considerations too. So more on cluster replication and linking too. But in this scenario, we have an active Kafka cluster. It's where everyone's producing and consuming from. But then we're also replicating to a passive cluster on standby. Ideally has a with the data. If there is an issue, disaster to strike in the active cluster and everything's offline, both producing and consuming applications can then transfer over to the passive cluster and start producing data there and consuming from that. So lowering your mean time to resolution and having things be online, but it also introduced another layer of complexity, which is what happens when your active cluster that went offline is now back online and you need to fail over back to your active cluster. Because the scenario you're now in is that you produce new data to your passive cluster that is not represented in the active cluster. So you're left to either try to replicate that back over to the active data, or a better scenario is that you've actually backed up all this data to an object store and can consume all of that directly into your newly back online active cluster. So the benefits for having a passive cluster, it's very quick to fail over. But the downside is you have to pay to host that passive cluster and keep it online in case disaster strikes. And then you need to be able to replicate back over to the active cluster to end that failover and get the active cluster back online with all of your applications connected there. Is much easier to do if you've got an object store as your single source of truth. You can consume all of those messages back in and ensure your state is like for like in both clusters.
And maybe it's worth saying that obviously Confluent have, so here we're focusing on MirrorMaker, Confluent have the cluster linking, which recently now it does go in both directions, right? So it does address some of the problems. The downside is the cost, right? It's in some cases overkill. Maybe you don't need that level of RTO for some applications or workloads, and you're going to pay a price for it. Not to discredit it, it's a very good solution, but it can be sometimes overkill and very expensive.
Thank you much. Good, important caveat to add. We're talking about MirrorMaker here. There are alternative methods, each with their own considerations. Just trying to get the wheels turning and show that there's something to think about regardless of how you're implementing your backup. And we put a lot of thought and consideration into our own S3 connectors. So we have an S3 source and sync. They've been a very hot topic and commodity for our customers today. They are both fully open source under Apache 2 license. And we do offer enterprise support as well. So you can be rest assured that your production workload running to and from S3 from Kafka can be fully supported with really streamlined SLAs too, supported by the experts on the panel here and our broader audience in Lenses team. And we provide the enhanced experience of using these connectors in Lenses, as we'll demo in a short bit. Now, more on the message structure of a Kafka message and the thought we had into our connectors. I'll bring on Stefan, Director of Engineering.
Hi, everyone. Thanks for joining today. I'm going to explain briefly what a Kafka message is, and I'm sure most of the information, but please bear with me. As Kafka messages usually are often referred as records, and a Kafka record is the smallest unit of data that you can write or read from Kafka. Therefore, the record is split in or is made out of a few components. One is the topic, and this is where messages are organized. It's a logical channel where you feed or you publish data. The next one is topic, a partition. It's a way to divide the topic to provide parallelism and scalability. Then there's an offset associated with each message. This is a unique identifier long that's ever increasing, and this number is, or messages within a partition are always kept in order. Last but not least, we have a key component. By convention, usually this part identifies the data that you push into Kafka, and it's used to publish to a specific or to determine the output partition. Then there's the value, which normally contains the actual payload that you want to send over Kafka, and it's information with the information that you need. And last but not least, there are the headers, which is a collection of key and value pairs that attach extra metadata that will give you more information about the Kafka record. When it comes to the S3 sync in the context of backup and restore, we've decided that the whole information, the whole message is to be kept into S3. And to do so, with the sync and the source, they agree on a format, which we call the envelope. And the format, as you can see on the screen, is split into the key value. And these two map exactly to the Kafka record key and value. And then within the metadata, we've captured the Kafka record metadata that I've mentioned about the offset partition, and I've left the timestamp earlier out, which is depending on the setting, it could be when the record was created at source, when it was processed, or when it was stored by the broker. And we also have an entry there for the headers. So when you store the data into S3, this envelope will end up, depending on the storage approach or storage setting that you set, into Avro, Parquet, or JSON files.
So yeah, as Stefan described, the idea of these two connectors is really so that it's optimized for a round trip. So the syncing to S3, where we retain the ordering and the partitioning, and then we can resource and rehydrate back either into the same Kafka cluster, maybe a different topic, but same Kafka cluster, or a different Kafka cluster. Now, the pattern that increasingly, for example, AWS promoting across their customers is that rather than spending money on a passive cluster, you have a single active cluster and you're using S3 as your backup. And if you ever to have a disaster on your active, you don't fade over to a passive, you just spin up a new active cluster and rehydrate. Now, it's important to say that backup and restore, there isn't a single solution that addresses all use cases. So you really have to design your backup and restore architecture and practices based on your requirements, what kind of workloads, what kind of SLAs and RTOs you have to meet. but this is certainly a very cost-effective way. The only downside here is it might take a bit of time to rehydrate the data, because potentially you're rehydrating months, if not years of data back into the Kafka cluster. The other thing to bear in mind, and I'm sure the audience knows about offsetting in Kafka, is although we can guarantee the order in the partition is maintained, we can't necessarily guarantee that when you're rehydrating, it has the same exact offset as it originally did when it was synced to S3. And we'd have to have another session to describe what you'd have to do in that scenario. I think most people are familiar with having to change offsets on consumers. That said, as we evolve these connectors, we're going to try and streamline that whole process as much as possible. But it's a very difficult challenge to address. And I'm just a little bit conscious of time, so we might go to the next slide.
Yep. This really briefly says that not only is S3 and object store great for backups and the security and peace of mind knowing that your clean data is stored somewhere, but it also enables a lot of actual profit earning and valuable integrations with data. Increasingly, we're seeing object store as sort of the Swiss Army knife as far as data integration and consumption. So you can use this for topic replication, where you're going from cluster to S3 to another cluster and consuming that, restoring to another environment, which I'll actually show you in a brief second. Another opportunity is to hydrate your data lake for consumption into a Databricks or Snowflake, some sort of lake house for historical analytics. And again, it helps you save on Kafka storage costs because you can reduce that retention period on your active cluster by storing that historic event log in object store. And increasingly, the AI and machine learning space is expanding and growing. Machine learning operations teams love using object store. It's super flexible and can be configured to meet their needs. So an ideal integration point for running and feeding AI and machine learning models based on real-time data.
Yeah, and very quickly, maybe we do a separate live stream just on this, but increasingly we're seeing this sort of architectural pattern where S3 is your master data lake. This is a data mesh architecture whereby effectively you're decentralizing your infrastructure, allowing different domains within your business to source from a common source. And that common source is increasingly this S3 data lake. So whether you want to replicate data from one Kafka cluster to another, you're actually using S3 as that middle person. But it doesn't have to be Kafka to Kafka. It could be Kafka to Redshift or Kafka to some Gen AI, LLM, and so on, as Adam was suggesting. So just in the interest of time, we're just putting it out there, but maybe we do a separate session just on that. We want to make sure we leave a bit of time for the demo.
Absolutely.
Feel free to ask any questions in the chat. In the meantime, we can answer in parallel.
Yes. Feel free to stop me if you have any questions. But as we mentioned, S3 is a great integration point for cluster-to-cluster replication since we have that full metadata envelope, and you can be assured ordering will be the same. So you're looking at two environments. If you can see my screen, on the right, we have what would be technically our production environment. And our goal is to replicate data from production into development to start messing around with it, testing new features. So I'll go to my topic page within Lenses. I can see the topic data here, or view it as a table. And super easy, I'll just select backup topic to S3. So I could deploy and configure a whole connector, which is great for specific use cases. But as far as peace of mind and routine operations, we will make it easy as possible and lower the barrier to entry for even someone from an analyst position to start working with Kafka, being fluent in syncing data to object store. With that, I just selected backup. I specified my bucket and my subpath, and I've deployed a connector. It's configured it for me. It's running. I've got records in and out. There's no magic here. I can go to my bucket, show my new subpath, and that's got my topic data right here, partitioned and ordered correctly. Fantastic. That's ready for consumption into my, again, data lake or machine learning model. But my end goal is to restore this to a passive or development cluster. So we'll name this restore. Awesome. I'll create my topic. I can easily search for it within our Lenses interface. I'm going to specify that this will be an Avro formatted topic. And then I'll source from S3 to restore the entire topic data. So I just need to provide the same information to complete the round trip. Awesome. Lenses is aware this is a restored topic. I can jump to the connector and see its status. So we're waiting for it to deploy and come online. And what's really nice too is that it's reflected in the topology as well. So I can see that I have my topic here and it's being restored. Check on its status. And indeed, I can see the messages and data flowing in, completing the round trip from production to S3 back into my passive or development cluster. Super brief, but is there any questions about what I just showed and how we're handling that in lenses today?
For this S3 connector, sync and source connector that we are using from the lenses portal, right? Is this a homegrown sync connector you have used, or behind the scene we have used a Confluent library to create a sync and source connector?
Yeah, no, these are entirely lenses developed to connectors, and those are available in our with all of our other Apache 2 license connectors as well. So it is solely a lenses open source connector.
And one more thing is, let's say when we are creating like a sync connector where we are syncing from Kafka or to S3, and if we want to manage the life cycle of the S3 bucket, uh, probably I know the answer, but I just wanted to confirm that the S3 life cycle is something that we will have to manage on our side itself, like wherever we want, however we are syncing, whichever bucket we are syncing, the policies that we apply will automatically apply. That has got nothing to do with this connector in itself.
That's right.
So
Yeah, you will have to, yes, that's something that you will configure on your end based on your own needs.
And then I think Harry got another question. His hand up.
Yeah, if you run these replications, where the worker nodes will run connectors, in where I install the lenses, or I need to provide any worker node or any node to run the connectors.
yes, that's a connector that deploys on your Kafka Connect cluster. So Lenses connects to your Kafka Connect cluster. We can manage the full lifecycle of connectors, monitor connectors there, alert on failure, and even auto restart. There's a transient error, but we are not managing that infrastructure for you. We're more of the development experience and interface on top of that, paired with all of our extra bells and whistles, and all structured under our RBAC and governance as well.
Okay, got it. Thanks.
Real quickly, I did want to mention that this is not the only connector we built, and we're building a lot more. So we're partnering with some of our largest enterprise customers to make sure that we're doing custom connector development to meet all of their requirements too. So definitely check out our repo, see what we have available, and let us know if there's anything that isn't available there that you'd like to see and integrate source systems with. So we are constantly developing more. We'd love to hear about your needs and what you guys are working on and looking to integrate using Kafka Connect. Sandra, if you can put the survey in the chat.
I have a question regarding the type of topics. We had already the same discussion, but can be useful, I think, for the session about the technical topics. Let's say consumer offset, connector offset, how the connector deal with that.
So can we replicate internal topics?
Yeah. There's alongside the thinking, let's say, data related topics, where it's available in our 5.0 branch, and we'll come into master branch as well on the Stream Reactor. The sync for consumer offsets, and we also released an application. Was also public in our repos that will be able to replicate based on the S3. So that will sync consumer offsets, not yet on the Connect system topics. But some of the system topics, if you look at them, they say, because they store JSON, you can replicate using the binary formats, and you can do a one-to-one. That's the case, but happy to discuss more in detail about that.
Sure. Thank you.
Next release will be including more metadata in the envelope, including consumer offsets, but you should be able to deploy the sync connector for an internal topic and back that up to object store.
Yeah, so in a nutshell, the S3 consumer offset sync will treat S3 as a key and value storage. And as it backs up the data in S3, you'll end up, for each consumer group, for each topic partition, you'll have the latest committed offsets. as it's been read from the underlying Kafka system topic.
How do you see, for example, in this case, instead of passing through connector to have, for example, a shallow copy of the disk for that specific folder in S3?
That is an option, but in general, because over that topic, you'll have offset information and also group status information that will be redundant. Basically, you'll care about your latest values. So yes, you can do a lift and shift of your disk files and then copying them over, but you'll just end up with a lot more data in S3. And that's not necessarily obviously the cost, but then Kafka having to reprocess and materialize that log.
And another limitation with that is that copying the disk files, effectively, we achieve infrastructure level backup, which has its benefits, but it's limiting in the sense that you can only effectively restore to the same infrastructure. But if you wanted that backup to restore to a completely different topic in a completely different Kafka, you would be limited because effectively what you've described in the disk is specific to that Kafka and specific to that topic. What's even more is you can reuse a more generic backup like the one we have, not only for restoring to Kafka, but potentially feeding off anything that can effectively understand the basic formats, Avro and Parquet. So you can think you can drive Athena from it, Presto, a Spark cluster, anything to really tap into that data. So it's much more flexible that way, if it makes sense.
And if you do have any more questions after this call, definitely feel free to join our community Slack. You can interface with the entire team there as well. This engagement's been great. I feel like we've all learned a lot, been able to show what we've been working on that we're all really excited about. Be sure to join next week as well. We're talking about sourcing complex data from S3 and consuming that into Kafka. Got a link to the Slack in chat.
What about have people fill out the survey of other connectors that you'd like to see? So Sandra shared a link with a form. And I don't know if I think we've got a slide with some of the connectors listed. Oh, yeah. So feel free if there is a specific connector that's important to your business. It helps on us prioritizing which ones to focus our attention and our engineering on. So click on the link and fill out the survey.
And feel free to share the survey with your team as well. In any event, we appreciate you taking your time today. Definitely let us know your feedback and what you're eager to hear and learn more about, and ask us any questions remaining on Slack in our community forum, Ask Marios.